Good morning, students. We are in the lecture 10th of the first unit of water resource engineering. We are seeing an important point, that is water requirement of crops. In the last lecture, we saw some terms related with water requirement of crops, that is crop period, base period, irrigation frequency, and the delta of a crop. In this unit, we will study about the next term, that is the duty of water. Okay, the term duty means the area of land that can be irrigated with unit volume of irrigation water. Fair and simple definition, it means the total area of an agricultural field that can be irrigated with unit volume of irrigation water. Okay, now unit volume, if we are seeing it in meter cube per second, or in other words in cumex, then unit volume means 1 meter cube per second, or 1 cumex. Okay, now we'll just rub it. Now quantitatively, duty is defined as the area of land expressed in hectares that can be irrigated with unit discharge, that is 1 cubic or 1 meter cube per second, flowing throughout the base period expressed in days. Okay, it means if for a base period, for example b days, uh, the total if the total number of area or land irrigated in hectares with unit discharge, that means, for example, if the base period is 10 days, then if we consider that the discharge flowing for that 10 days in 1 meter cube per second continuously, the water received by the field is 1 meter cube per second for the entire 10 days, then the total area of land in hectares which will be irrigated with that discharge, it is known as duty. Okay, now if we consider, we'll see an example. If water flowing at a rate of 1 cubic meter per second, that is 1 cubic rate of discharge, and it runs continuously for b days. Okay, that b days is the base period, and it matures 200 hectares, then the duty of water for that particular crop will be defined as 200 hectares per cubic to the base of b days. Okay, now we'll see again, what is the rate of discharge. It is 1 cubic meter per second, or 1 cumex, and the water is running continuously for b days. It matures 200 hectares of crop. That means the water the discharge of water which you have provided has totally irrigated over 200 hectares. Okay, the crops in a total area of 200 hectares uh, have received the water, and they have matured. That means the crops have grown from sowing to harvesting. Then the duty of water for that particular crop will be defined as 200 hectares per cubic. So as we can see here, the unit of duty is hectares per cubic. Okay, hence duty is defined as the area irrigated per cubic of discharge running for base period b. Okay, it is the area irrigated per cubic. Area is in hectares. Now the duty is generally represented by the letter capital D. Now we have seen what is meant by duty. We'll see the relationship between duty and delta. Okay, so let there be a crop of base period b days. Okay, let there be a crop which has a total base period of b days. Base period means the time of the first watering at the time of sowing to the last watering before the harvesting. Okay, the time period between those two events, it is known as base period. So in this case the base period of the crop is, we will consider B days. Now let 1 cubic of water be applied to this crop on the field for B days. Okay, now for B days, now the B days can be any number of days, 100 days, 120 days, 200 days, any number of days. Now for that total amount of B days, we are continuously providing 1 cubic or 1 meter cube per second of water to the crop. Okay, so the volume of water applied to this crop during B days will be, okay, the total volume of water which will be applied to this crop at a rate of 1 meter cube per second for B days is, okay, so here is the volume. Okay, this one is meter cube per second into B days. Okay, this B is in days. Now these days we have converted it into seconds. Okay, so as we know, discharge is equal to volume upon time. Okay, discharge is equal to volume upon time. So volume will be equal to discharge into time. So here discharge Q is 1 meter cube per second or 1 cubic, and time is B days. Now this B days we have converted into seconds. So it is B into 24 hours into 60 minutes into 60 seconds. Okay, so the total volume total volume of water applied to the crop for B days is 86,400 B. Okay, this is the total volume of water, and as we have converted B into the days into seconds, the unit will be cubic meters. Next, now if we see the definition of duty, it is 1 cubic meter supplied for B days will mature d hectares of land. Okay, as we have seen in the definition of duty, it is nothing but the area of land in hectares which is matured by applying 1 cubic meter or 1 cubic water for a total of base period B days. Okay, so now this volume V, okay, that is 86,400 B, this total volume will mature d hectares of land, okay, or 10 raised to 4 d square meter of area. Now what we have done here is we have converted hectares into square meters. Both are the unit of area, so for our calculation purposes we have converted hectares into square meter. Now 1 hectare is equal to 10 raised to 4 square meter. So this volume of water, that is 86,400 B, it will mature d hectares or 10 raised to 4 d square meter of area. Okay, so the total depth of water applied on this land will be, okay, now we have to find out the total depth of water. Now we know another formula of volume is area into depth. Okay, so depth will be equal to volume upon area. So the volume is given here 86,400 into B upon area. Area is 10 raised to 4 D or D hectares. Okay, so the total depth of water will be 8.64 B upon D meters, where B is the base period and D is the duty of water. Now by definition, this total depth of water is called delta. As we have seen in the definition of delta, it is the total depth of water which is required by the crop for its maturity. Okay, so it is nothing but this total depth of water, that is 8.64 B by D, is nothing but delta. Okay, now delta is equal to 8.64 b upon d. So if we see here, delta is inversely proportional to duty of water. As the delta increases, duty decreases. That means as the total depth of water increases, duty will decrease, and as the total depth of water will decrease, the duty of water will increase. Now next what we have done is we have converted this from meters into centimeters. Okay, delta is equal to 864 b upon d. Now here delta is in centimeter. Okay, this delta, it is in centimeter. B, that is the base period, is in days, and D is duty in hectare per cubic. Okay, so these all three values are having different units, but the final answer we get is in centimeter. Now B is in days here. Okay, but what we have done is we have converted those days into seconds earlier in the first step. So don't get confused here. We have already converted this B, value of B, from days into seconds. D, that is duty, is in hectare per cubic. Okay, now we have converted the hectare into square meter. Okay, so the final answer we get will be proportional. Okay, so the final answer is delta is equal to 864 b upon d, where this is delta, b is base period in days, and capital D is duty in hectare per cubic. Okay, now we'll solve a numerical for relationship between duty and delta, and you will understand what we are doing here, or what is the relationship between duty and delta. This is the question: find the delta for a crop when its duty is 864 hectares per cubic. Okay, duty, that means capital D, it is 864 hectares per cubic on the field, and the base period of this crop is 120 days. Base period is nothing but capital B, as we know. So we'll solve the problem. If you remember, the formula is delta is equal to 8.64 b by d in meters, and delta is equal to 864 b by d in centimeters. Now we have got b and we have got d. We have to calculate delta. Okay, so delta in centimeters. Okay, the equation is 864 into b by d. Now B, capital B, is 120 days, it is given in the problem, and capital D, that is duty, is 864 hectares per cubic. Okay, so the final answer is 864 into 120 B divided by D, which is 864. So the final answer, delta of the crop, is 120 centimeters. Hope you have got the problem. It is a simple formula. It gives us relation between duty and delta. Okay, now next we will go to the next point, duty at various places. Okay, so now duty of water for a crop is the number of hectares of a land which a unit flow of water can irrigate for b days. This, you know, is the definition of duty. It is the total number of hectares of a land which a unit flow or a unit discharge of water, that is 1 cubic, can irrigate for b number of base period. Okay, therefore if water requirement of a particular crop at a particular location is more, then lesser number of hectares of land will irrigate. Okay, that means if the water requirement of a particular crop is more, if more water is required for the growth of a crop, then it will mean that lesser number of hectares of land will be irrigated with the same amount of water. Okay, hence if water consumed by a crop of a given base period is more, its duty will be less. Okay, now if we consider two crops, sugarcane and wheat. Okay, now the water required by the sugarcane is more as compared to wheat. Okay, so uh, the water which is available for sugarcane, it will irrigate less number of hectares, while the water available for wheat will irrigate more number of hectares, because wheat requires less amount of water and sugarcane requires more amount of water. Okay, so the duty of sugarcane will be less and the duty of wheat will be less. Okay, so now this is an irrigation transport system. Okay, now before explaining duty, let me just explain this canal system. Okay, now this is a river, natural flow of the river. Now what we have done here is we have constructed a weir or a barrage. Okay, after constructing this weir, what happens is the water level at the upstream side is increased. Okay, and as the water level in the upstream side is increased, the raised water level goes in this canal. Okay, now this is the main canal. Okay, from the main canal the water goes into branch canals. Okay, which are connected to the main canals. Now from the branch canal the water goes to the distributary canal. Okay, now many distributary canals are connected to a single branch canal. Okay, now from the distributary canal the water goes into minor canal. Many number of minor canals are connected to a single distributary canals, and from the minor canal water goes to the individual field channel which is constructed by a farmer, and from that field channel it enters the agricultural field. Okay, now if we have to understand the concept of duty, if we see here, the discharge at the main canal, the discharge at the main canal will be more in the main canal. It is almost 60 cumex. Okay, now when the water enters from the main canal to the branch canal, the discharge gets reduced. Now here the discharge is a little bit greater than 30 cumex. Now from branch canal the water enters into distributary canal, where the discharge decreases below 30 cumex, that is 30 meter cube per second. From the distributary canal the water enters the minor canal, where the discharge gets uh, below 10 cumex and greater than 2.5 cumex. And from the minor canal the water enters the field channel, whose discharge is less than 2.5 cumex. So as we see, as we go from a canal head from a main canal to the field channel, the discharge of water goes on decreasing. Okay, now if we see duty, the unit of duty is hectare per cubic. Okay, it is hectare per cubic, and cubic is nothing but meter cube per second, that is discharge. That means if the discharge is reduced, duty will increase. As we see here, duty is inversely proportional to Qmax, that is discharge. So if discharge increases, duty reduces, and if the discharge reduces, the duty increases. So if we see here, in the main canal the discharge is greater than 60 Qmax. As the discharge is greater, here Qmax is greater, duty will be less in the main canal. In the branch canal, here the discharge reduces. Now as the discharge will reduce, duty will increase. So in the branch canal, the duty will be greater than in the main canal. Similarly, if we go to the distributary channel, here discharge becomes less than 30 cubic, that is discharge is reduced, and as discharge reduces, duty increases. Similarly, in minor, again the discharge will reduce and duty will increase. Similarly, in the field channel, discharge will reduce, duty will increase, and finally in the field the discharge is minimum. So here the duty is maximum in the field as compared to the main canal. So if we summarize it, we can say that as we travel from the main canal to the agricultural field, the duty goes on increasing and the discharge goes on decreasing. Okay, hope you have understood this. This is not in the syllabus, just I wanted to explain it. Next, we will see the factors which affect duty of water. Okay, now the duty depends upon the following factors. First is the type of crop. Now, as we have seen, if a crop requires more water, duty will be less. Okay, uh, crop requires more water means discharge will required will be more, and if discharge increases, duty will be decreased. Okay, and vice versa. That means if crop requires less water, duty will be more. Okay, so duty depends upon the type of crop. Next, climate and season. Duty also includes the water lost in evaporation and percolation. Okay, duty is not just the water which is utilized by the crop, but it also includes the water which is lost due to evaporation and percolation. As these losses differ with season and climate, duty will also differ. Okay, for example, in a cold climate or in a wet climate, there will be less evaporation and percolation, so the losses will be less. That means the amount of discharge required will be less, and hence duty will be more. Okay, but in a hotter climate, in an arid dry climate, what will happen is there will be more losses due to evaporation and percolation. That means more amount of discharge of water will be utilized, and as the more amount of discharge of water will be utilized, duty will reduce. You just have to remember, duty is inversely proportional to discharge of water. Next is the useful rainfall. If some of the rainwater falling on the agricultural fields is used for the crop, then less amount of irrigation water will be required for the crop. As less irrigation water will be required, duty will be more. Okay, now you have to understand one important thing. Duty of water is a concept applied only to irrigation water and not for naturally occurring rainwater. Okay, so if there is more amount of rainfall which is more useful to the crops, it will mean that we'll require less amount of water from irrigation, and as less amount of water will be required for irrigation, the duty will be more. Okay, because here discharge is reducing of irrigated water, so it will mean that duty is more. Next, type of soil. If the permeability of soil is high, there will be more percolation losses and the duty will reduce. Okay. Now, if the permeability of soil is high, it will means that the soil soaks up more water, and the water travels through the soil very fast to the downward groundwater table. Okay, so more water will be lost due to percolation, and as more water is lost, that means the crop has required more discharge of water, and it will mean that the duty is less. Next and last point is the efficiency of cultivation methods. If the cultivation methods applied are faulty and less efficient, wastage of water will be more, and hence duty of water will naturally decrease. Okay, if we are using faulty and outdated methods of cultivation, there will be more wastage of water. More wastage of water, that will mean the more amount of water discharge is wasted, and the more amount of discharge is required for a crop, it will mean the duty of the crop water will reduce. Next slide we'll see the importance of duty. Why is duty important in water requirement of crops? Okay, so the main point, it helps us in designing an efficient canal irrigation system. Okay, that is the most important point of duty, that is it helps us in designing an efficient canal irrigation system. We as civil engineers, we have to design efficient canal systems uh, that start from a river to main canal to distributary canal. Okay, to minor canals to the field channel up to the field. As civil engineer, we have to design the whole system. So the study of duty helps us in designing an efficient irrigation system. Okay, if now first point, if we know the total available water at the head of a main canal, okay, and the overall duty for all the crops required to be irrigated in different seasons of the year, the amount of area which can be irrigated can be worked out. Okay, so in the first case, if we have a canal irrigation system available, okay, and we know the head and discharge of water available at the main canal, and we know the values of duty for all the crops which are required to be irrigated in the region, then the amount of area which can be irrigated can be calculated. Now inversely, second important point, if we know the crop area required to be irrigated, and we know the values of duties for the crop, we can work out the discharge required for designing the canal. Okay, so second point, if we know the amount of crop area which has to be irrigated, and if we have the values of duty for all the crops, then we can calculate the discharge which will be required for the crops, and when we calculate discharge, then we can design an efficient irrigation channel system. Okay, so these both points are important. If uh, if we know the uh, discharge of water available with us in a canal, we can calculate the area of crop which can be irrigated. And second point, if we know the area of the crop which has to be irrigated, then we can design an efficient canal system. But in the both cases, we should know the overall value of duty for all the crops. Okay, now here we have been given duty of certain crops. Okay, now if we see here, duty of sugarcane and duty of rice are very less as compared to perennial crops and other rabi and kharif crops. Okay, Now duty of sugarcane and rice is very less because more amount of discharge of water is required for the maturity of sugarcane and rice crops. Hence, the duty will naturally, in the case of sugarcane and rice, will decrease. Okay. Now, in the case of perennial and hot fodder, less amount of water is required for irrigation. That means less discharge is required, and as less discharge is required, the duty will be more. I hope you have understood the connection between duty and discharge. Now, last point in this unit we are going to see is methods of improving duty. What are the methods which you are going to apply to improve the duty of the crop? That means improving duty indirectly means reducing the amount of water to be supplied. In the process, we save water. Our end goal is to save water. Now, there are two different types of precautions that we will take in order to improve duty. First precaution will take in field preparation and sowing. Now, more than civil engineer, these precautions should be taken by farmers. So it is necessary to educate the farmers so that they can manage field preparation and sowing properly. These are the points which are these are the precautions which can be taken. First, the land which is to be leveled, the land which is to be used for cultivation should as far as possible be leveled. Okay, if the land is not level, if the land is sloping, more discharge of water will flow through the slope and it will exit the agricultural field, and hence more amount of water will be wasted, and as more amount of water is wasted, the duty will decrease. So in order to increase the duty, we have to level the lands so that there is no wastage or drainage of water. Next is the fields should be properly plowed to the required depth. Okay, so that there is proper permeability. Next, improved modern cultivation method may be preferably be adopted. We have seen in the last slide how if we use outdated and less efficient methods, the duty is going to decrease. So in order to increase or improve duty, we will use improved modern cultivation methods. Next, porous soils should be treated before sowing crops to reduce seepage of water. Porous soils means permeable soils. That means the water travels through these soils in the downward direction very fast. Okay, if that happens, then less amount is left for the growth of the crop, because if the soil is more porous, that water will travel through the soil very fast and it will go down to the groundwater table. Okay, and it will mean that more amount of water will be required for irrigation and it will decrease duty. So in order for that to not happen, we should treat porous soils before sowing crops so that the seepage of water through the soil is reduced. Next point, alkaline soil should be properly leached. Alkaline soil, these are two important words. Alkaline soils, they should be properly leached before sowing. Now what happens in alkaline soils is that the soils become impermeable. Okay, the water do not enter the pores of the soil, and this can be pretty dangerous or pretty useless for growing crops. If no water is seeped into the spores of the soil, the root of the crops will not get any water for growing. Okay, and the water will be wasted, and as the water is wasted, it will decrease duty. So the alkaline soils should be properly leached. That means there should be proper mechanism for the water to be seeped into the soil. And last is the manure fertilizer should be added to increase water holding capacity of the soil. Okay, manure fertilizer should be added to increase water holding capacity of the soil, so that the soil keeps more water inside of it. Okay, for the crops to grow. And lastly, the rotation of crops should be prepared. Rotation of crops means if you have planted sugarcane in this season and after the sugarcane is harvested, we should not again plant the sugarcane. That is wrong. Instead of sugarcane, we should plant another crop like soya bean. That is nothing but the rotation of crops. Now this process helps in improvement of duty. Now next precautions, it is in handling irrigation supplies. Okay, this concerns the job of civil engineer. What the civil engineer should take precautions in order to improve duty. Okay, now the source of irrigation water, okay, whether it be canal or tube wells, etc., or dams, for the reservoirs of a dam, they should be situated within the prescribed limits of the agricultural land which has to be irrigated. Okay, so the source of water should not be very far away from the land, from the agricultural land, because it will uh, result in more wastage of water during the transportation of water, more wastage such as evaporation wastage or evaporation loss or percolation loss. Okay, next is canals carrying irrigation water should be lined. Okay, now lined canals, it means we apply a layer of concrete to the sides of the canal. Okay, if these layers of concrete are not applied, what will happen is the water will seep into the soil bed soil or the bed of the canal. But if we line the canals properly, as concrete is an impervious structure, no water will be seeped, so it helps to reduce seepage, and as seepage is reduced, wastage of water will be reduced and it will improve duty. Now in case of pipe system, RCC pipes are preferred in order to reduce field water requirement, because uh, the wastage of water or the losses in RCC pipes are less as compared to the other pipes, so it helps to improve duty. Next, if we are using a surface irrigation method, then the free flooding of fields should be avoided. Now free flooding method we have seen in the first or maybe second lecture. Free flooding methods are check irrigation, border irrigation, and so on. They should be avoided, and furrow irrigation method should be preferably used, because in furrow irrigation method the surface area of water is reduced, and as the surface area of the water is reduced, the rate of evaporation also reduces. The amount of surface area required for evaporation reduces, so hence there is less wastage of water. And last point, instead of surface irrigation, we can use subsurface and drip irrigation methods, in which there is very much less amount of wastage of water, and hence they should be preferred in order to improve duty. Okay, so in this lecture we studied about duty. Okay, in the next lecture we'll study about the types of soils. Thank you.